Mike Levin. Tuesday, October 10th, 2017. At around, well, it's actually on the early side. I think it's around 8 a.m. So I'll be getting at least an extra hour of focus time in that I normally don't get. And I had planned on putting some vampire time in during the night, getting that uniquely focused in the zone time that comes most easily at night, but I was exhausted. I got home from the Catskills at about 4 a.m. and by the time I was done packing, having closed the place for the winter, it was around 4:30 a.m. and I was lucky to have gotten 2 hours of sleep before yesterday, and I had a less productive day than I expected, unsurprisingly, yesterday. And I am facing some of the biggest data samurai challenges of my career right now. And I shall get through it because nothing about it is actually any harder than anything I've ever done in the past. It is just a replatforming, remapping, learning new patterns, going through my 10,000 hours. Hopefully it won't take that long. It's similar enough to everything else I do that I think I'm on the accelerated path, but it is learning to let go of my purely SQL thoughts and thinking and very English-like way of stringing up ideas into, left inner and left outer joins to a more NumPy, that is to say number array, syntax for doing the same kind of data work: joins, unions, group bys, aggregates, roll-ups, reports of every form that are back-ended. They say back-ended because, there's the data living somewhere, which is likely in some sort of raw log file-like format, because life happens sequentially. This happens, then that happens, then that happens. And the most honest and accountable, albeit not all that efficient, ways to express and store that kind of data is in a log file, what most of us would think of as weblogs, where you write to a file and you write to a file and you keep writing to that same file forever, and then you've got those problems that everyone knows exists with weblog files. They fill up, they're on multiple servers and have to be marshaled and unified to do queries across your entire server farm. Well, the point is that your original source data is often in that form, and it's large and has parsing issues in order to turn something that's a lot like text files back into data so that you can use a querying language against it. And then the nature of the querying language that you use against it plays a very large part in defining your capabilities. So one thing that SQL does all the time that very few people think about is execution plans, magically and in the background, because SQL as a language is a lot like HTML, where you don't say how something is going to be carried out, you just ask for it to be carried out in the most general abstract terms that is suitable to the API model that is HTML and SQL. It has driven the popularity of both things forward, and that leaves it in the hands of the people who make the tools to interact with the data to do all the hard stuff, all the efficiencies and optimizations. So that includes execution plans, the order of operations. Things happen in the background that you don't even know are happening in order to get the work done efficiently. And there's execution plan retention, so that when the database encounters the same query, it knows to use the shortcuts and even the temporary tables and indexes it quietly built in the background to help itself. So that's execution plan retention and auto indexing. And when you're dealing with SQL, you're usually dealing with some larger database system with an administrator in the picture who's made all these decisions, and you might even have views that you can hit, so you don't have to hit the raw data table, so your queries are easier. But when you're getting rid of SQL from the picture and you're putting in its place Python data objects, even though they're not native to the Python core libraries like dictionaries, tuples, and lists, you're using numeric arrays, n-dimensional numeric arrays, which follow almost the same Pythonic API syntax as the other data objects, so you feel quite familiar with it. But to express concepts, you're either, expressing it with square brackets and some sort of index inside, either a numeric or keyword index, or dot method names. That's what Java people call them, at least. I don't know what we call them in Python, but I guess they're just functions and that are carried around as part of the numeric array objects, so that you can do all kinds of calculations on them. And a lot of those dot this and dot that, like dot mean or dot count, are aggregate functions. They're these roll-up things that we recognize from SQL world, where it would be used in a different way, in a more natural language, English, keyword, space, keyword, space, keyword. I guess that's an expression. Select column names from table name, where the value in a certain column is equal to such and such a value. Limit 100 if it's a huge table. Versus df open bracket, close bracket with column names inside the open close bracket, dot mean, for example. And then there's aggregate, an aggregate method, so that you can do group bys by multiple functions like sum. So the syntax changes, the expressions change, the expressiveness and capabilities seem to be, on par with each other. I would imagine anything you could do in SQL, you can do pretty well in Pandas. But it does appear that certain things are in fact more easily accomplished in Pandas, more readily expressed, less SQL-like things, a lot of operations on single columns that I wouldn't necessarily think to do in SQL. SQL, I tend to be either getting, well, I guess it's not true. I just don't use SQL that often to get a list, a single one-dimensional list of data, but it's something you could easily do. But your ability to do that just as a generic capability from anywhere within Python, because of the Pandas library, is a wonderful thing, because as we know, sequences in Python are easily transferred around. So it might be some special object under NumPy and Pandas, but if you know how to do something generically on a Python list, you'll either be able to do it directly on that object in NumPy or Pandas, or you can convert it to a native Python list and do it there, because the conversion takes place so easily. Anyone who moves JSON, native JSON, back and forth between Python knows this to be a fact. It's kind of a pain extra step. It's like a mapping layer or whatever, but it's always one-to-one, because the objects you can express in JavaScript object notation, JSON, is the pretty much the same as you can express objects in native Python. And okay, so where this is leading me is that I don't think in Pandas or NumPy as naturally, as spontaneously as I do in SQL. Almost anything I would wish to do, from inner to outer joins to unions, which is like stacking tables on top of each other, sorting and grouping by, and distinct, all kinds of filters with where. I can just do it in SQL. I've reached that point, whatever that is, the 10,000 hours. And I have not reached that point with Pandas, and I'm only just standing there at the base of the mountain. And I'm banking on the fact that because I know how to do Pythonic things, and Pandas is a reportedly very Pythonic interface, well implemented, and all the things that you learn about NumPy also apply to Pandas, so learning NumPy is a great way to also learn Pandas to improve your expressiveness. You are building and creating expressions, and it's all about taking things that are in your head and putting it into words and symbols, you know, in a system, or talking it into the air. That's coding, that is encoding. And expressiveness is the skills and style and intelligence by which you can express and encode your ideas to deal not only with the problem right before you now, but to deal with solving that problem generally over and over into the future. Being your own execution planner and execution plan retainer. So you need ways to remember what you did in the past that worked. GitHub, or Git in general, but GitHub in particular, and even with its gist system, which is not even Git repos, but is just little snippet libraries of patterns that don't justify their own repo, is a great way to do that. I'm taking advantage of the GitHub gist system more often. And a deep understanding of design patterns and the lies and the damn lies that Java people will have you believe about patterns being expressible in one true correct way in Java, and anyone else using, you know, the builder pattern has to do it the Java way, named tuples, or named tuples, if you will. And map reduce, expressible as list comprehensions, and the list goes on. Python has many design patterns built into it, so you hardly even need to think that they are design patterns. And because you internalize things like list comprehensions, MapReduce is just a general principle. It gets transparently blended into your day-to-day work without you even know you're doing that. And if you're not technically taking advantage of the parallelism implied by doing MapReducing list comprehensions, well, first you will get to the maximum capability allowable on your CPU speed, although you might not get the multi-core advantage if NumPy is being used because it's compiled in C, blah, 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 blah. I really digress. But you could use different Python execution environments like Euphora in order to actually get the parallelism you want, although I don't know if NumPy is ported to Euphora yet. But anyway, all that kind of stuff is in the present, you know. I'll be video casting each of these hurdles that I overcome at work, and I think the current one is one of the most interesting I've faced in my career here, which is I'm a data person. I really do manipulate data a lot, and mostly by SQL. I'm also a Python person. Now I have to bring those two together. Thanks for joining me. Hope to talk to you again soon, and don't forget to subscribe.